Today we're going to learn about more complicated function notation. Basically, I'm looking at the composition of two functions together. So you should already understand the function notation if you're watching this video. So I'm just going to do an example where we've got f of x equals, let's go with 3x plus 2. And I'm going to introduce a second function. Now I'm not going to call it f of x, I'm going to call it by a different letter. Either usually g of x or h of x are the most common ones that you'll find in textbooks. I'll say, well, let's say g of x equals x plus 3. So I've got two functions. Now what I'm going to do is I'm going to find FoG, f of g. Okay, FoG stands for f of g. Often the textbooks use either FoG or they might say find f of g of x. Okay, so you can see, I need another bracket there. So basically these two things mean the same thing. We're either finding FoG or f of g of x. Okay, it's just two different ways of writing it. So what I'm going to do is, remember, it's a substitution thing. So this is f of x, I want to find f of g of x. So g of x is what I'm going to substitute in for x within this function. So let's find FoG, f of g of x. So f of g of x looks like this. So we just concentrate on f, the function, f of x, and we go 3 bracket. Now when we come across an x, we need to substitute this in instead. So it's x plus 3. And then we continue with the function, and it's just plus 2. You then need to, of course, simplify this. So this is a bracket. I need to expand the brackets. I've got 3x plus 9 and then plus 2. We can simplify that to give us 3x plus 11. Now you can also find GoF, which is g of f of x. So I'll just clear some space. Okay, so GoF, g of f, also written as g of f of x. Okay, which means the same thing. Now, oops, should be back there. All right, so what I'm going to do now, because I'm finding the function g in terms of f, what I need to do is focus on this function, because this is my function g of x. And wherever I see an x in the function, I'm going to substitute f of x into that. So let's begin. So g of f of x equals, so we've got x to begin with, and then we're going to plus 3. Well, x has to be all of this, so it's 3x plus 2, and then I need to then add 3 on the end. So here's the f of x here, and then simplify it. So we've got 3x plus 5, and that's our g of f of x. All right, so I've got a different example. This is a bit tricky because it involves a squared term. Now what I'm going to do is I'm going to find GoF, g of f of x. G of f of x. Okay, so because my g is at the beginning, I'm focusing on this function. So I've got x. Now I've come across an x straight away, so I need to put the x plus 2 in its place, x minus 2, sorry, in its place and square it. So that x squared plus another x. So I need to put x minus 2 there. I don't need the brackets here. I'm just putting that there so you can see that it's come from there. And I'm going to now subtract 5. I'm going to need to use FOIL for this to simplify this. So of course it's a perfect square, so it's nice and easy. You've got x squared minus the 4x plus the 4 for that one. And then this is plus x minus 2 minus 5. Now we can simplify that all together to give us x squared. We've got minus 4x plus an x gives us minus 3x. And then we've got plus 4 minus the 5 is minus 1 minus the 2 gives us negative 3. And that's g of f of x. Now let's suppose we had to find g of f of x of 1. So g of f of x of 1. So we just use our result from here, and we're substituting 1 wherever we see the x. So I've got 1 squared minus 3 times 1 minus 3. 1 squared is 1 minus the 3 gives me minus 5. And that's everything you need to know about complicated composition of functions.